All right, so you ready to dive into a world where robots are like conquering some really tough terrain?
Yes, let's do it.
You with me on this one. We're
Yeah.
talking about those classic sci-fi scenes, where you see robots just like gliding over crazy obstacles with, that human-like grace.
Yeah.
Turns out though, getting that to work in real life, it's a lot harder than those special effects make it seem.
Yeah. It's a lot of work.
It really is. So today we're gonna take a deep dive into a research paper that's really trying to crack this problem. It's called BeamDojo, Learning Agile Humanoid Locomotion on Sparse Footholds.
Catchy title.
Catchy title, right? And this isn't, your average like Roomba, bumping around.
Yeah.
We're talking about like full-on humanoid robots, the ones designed to walk on two legs.
Yeah.
And they're taking on surfaces like stepping stones, balance beams, even gaps.
It's pretty amazing what they're doing.
Yeah, it is. Think about it, though. The potential here. Search and rescue robots that can navigate like disaster zones or exploration robots that can go through uncharted territory. It's pretty exciting stuff.
Yeah. It's really cool to think about all the possibilities.
It is.
Yeah.
So to kind of kick things off,
Yeah.
can you help us understand just what makes this so difficult for robots, especially these humanoid ones?
Right.
Why is walking on a balance beam such a big deal for them?
It's interesting because even building a robot to walk on two legs on like a flat surface is a huge challenge.
Right.
But when you throw in these like sparse, irregular footholds, it just becomes exponentially more complex.
I can imagine.
Yeah. And, a lot of it comes down to this fundamental difference in like foot geometry
Okay.
between humanoids and a lot of other types of robots.
Interesting.
Yeah. So think about like a quadruped robot, something like a dog-like robot.
Yeah.
They often have these point feet,
Uh-huh.
which make finding a stable foothold relatively straightforward.
Right.
But humanoids, with our polygon-shaped feet.
Yeah, like squares, rectangles, triangles, all that.
Yeah, exactly. We need a much larger contact area for balance.
Makes sense.
It's not just about finding a point to stand on. It's about making sure like a significant portion of the foot surface is in contact with the ground so you don't tip over.
Right. Yeah, it's like trying to balance on a skateboard versus trying to balance on like a large textbook or something.
Yeah.
The textbook gives you more area, but it's so much harder to like keep it steady.
That's a great analogy.
Yeah.
And because of this, these traditional robotic control methods that work really well with point-to-point contact calculations,
Right.
they just don't cut it for humanoids on these challenging terrains.
So they need a whole new approach.
Exactly. And that's where BeamDojo comes in.
BeamDojo. I love that name.
Yeah, that's a good one.
It sounds like some kind of elite training academy for robots.
Well, it's pretty fitting, actually. The name combines beam for the types of obstacles they're focusing on, and then dojo, like a martial arts training ground, which kind of reflects the learning process they're using.
Gotcha.
So BeamDojo is a reinforcement learning framework. Imagine like a student practicing a move in a dojo. They're failing, refining.
Right.
That's essentially what these robots are doing in a simulated environment.
Interesting.
Constantly learning from their mistakes and improving their skills.
So no robot roundhouse kicks just yet.
Not yet.
Not yet. But they are getting pretty good at this balancing act. Huh?
They're getting there.
That's awesome. So what makes BeamDojo's approach so unique? What are like the secret ingredients in their training program?
Well, there are two key innovations that really set it apart.
Okay, I'm listening.
The first is something called foothold reward.
Foothold reward.
Yeah, it's a reward system designed to incentivize precise foot placement.
Okay.
So remember how we talked about the importance of large contact areas for humanoid balance?
Right.
Well, this system rewards the robot for maximizing that contact within the safe zones of the beams and stepping stones.
Oh.
And here's where it gets really interesting. They don't just look at whether the foot as a whole is in contact. They analyze multiple points on the robot's foot to see how much is actually touching the surface.
So it's like pressure map of the robot's foot?
Exactly.
Wow.
It gives them this detailed feedback on every step.
So it's more than just like step here.
Yeah.
It's about like how the robot is stepping.
Exactly.
It's almost like it's developing a sense of touch through its feet.
That's a great way to put it.
That's really cool.
Yeah, and that level of feedback is just crucial for the robot to learn those fine-grained motor skills that it needs for balance.
Makes sense.
And that kind of brings us to the second innovation,
Okay.
which is something they call the double critic.
Good book critic.
It's this two-pronged evaluation system where two critics, which are essentially algorithms, analyze the robot's performance.
Gotcha.
So one critic focuses on the overall smoothness and efficiency of the robot's movement.
Okay, so like a coach evaluating the overall form of an athlete?
Yeah, exactly.
Wow.
And then the second critic zeroes in specifically on the robot's foot placement accuracy on those like precarious footholds.
So like a specialist coach
Mhm.
honing in on like the finer details of the technique?
Precisely.
I like it. I like it.
So it's kind of like having two coaches, one looking at the big picture and the other obsessing over the footwork.
Right. And this helps the robot learn both how to walk gracefully and how to avoid taking a tumble.
Exactly. It makes sure that it's not sacrificing one for the other.
Right. That's smart.
Yeah.
So it's like teaching someone to ride a bike.
Yeah.
You wouldn't just throw them onto a busy street right away.
No, definitely not.
You'd probably start with training wheels.
For sure.
And that's kind of the logic behind BeamDojo's two-stage training approach, right?
Exactly.
Okay, so they're easing the robots into this balancing act. No robot face plants on the first try.
That's the idea.
Good.
Yeah.
So in the first stage, they train the robot in a soft terrain environment.
Right.
What does that mean?
So this means that the robot is technically walking on flat ground in the simulation, but it's receiving information about those beams and stepping stones as if they were physically present.
Okay.
It's kind of like practicing your golf swing indoors with a simulator before hitting the actual course.
Right. Yeah, that makes sense.
Yeah.
So they're giving the robot a chance to get the basics down without constantly falling and restarting.
Exactly.
It's building that muscle memory, so to speak,
Yeah.
in a safe space.
Yeah.
So what happens in stage 2 then? Do the training wheels come off?
That's when the training wheels come off.
Okay, bring on the real deal.
Yeah. In stage 2, the robot graduates to the real deal. The stepping stones, the balance beams, the whole shebang.
That's awesome.
Now it's facing those complex footholds in all their glory,
Right.
but it's doing so with a foundation of skills learned in that softer environment.
So now I'm really curious. They've trained these robots in a simulation. They've got the mastering balance beams in the digital world.
Yeah.
But how does this translate to the real physical world? Can they really walk the walk outside of the simulation?
That's the ultimate test.
It is.
And that's where things get really tricky.
Bridging that gap between simulation and reality, that's like the holy grail of robotics, isn't it?
It really is. It's the challenge that keeps us roboticists up at night.
I bet. So how did the BeamDojo team tackle this challenge? Did they just like cross their fingers and hope for the best when they put their robot on a real balance beam?
Well, not quite. They actually had a pretty clever strategy. First, they equipped the robot with a LiDAR sensor.
Okay.
It's kind of like giving the robot 3D vision. It allows it to constantly scan its surroundings and build this real-time elevation map.
So it's kind of like the technology used in self-driving cars to navigate roads.
Exactly. Very similar concept.
Okay, so the robot has eyes on the environment. It's not going in totally blind,
Right.
but I imagine the real world throws some curveballs that a simulation just can't fully replicate.
Oh, absolutely.
So how do you prepare a robot for that?
That's where it gets really interesting. During that simulation training we talked about,
Right.
they use a technique called domain randomization.
Domain randomization.
Yeah. Essentially, they made the simulation intentionally chaotic.
All right.
Think of it like training for a marathon on a treadmill, but the treadmill is randomly changing speed and incline.
So instead of a smooth, predictable virtual world,
Yeah.
they're throwing in like virtual potholes and wind gusts.
Exactly.
Tough love for the robot.
It is, but it's what makes the robot more robust and adaptable.
So it learns to handle those unexpected variations.
Right.
And then it's less likely to get thrown off by, the real world's imperfections.
Exactly.
Okay, so the big question, did all this fancy footwork and chaotic training pay off?
Well, the results were pretty remarkable, actually.
Spill the beans.
Huh.
How did the BeamDojo robot perform in these real-world tests? Did it live up to the hype?
I think it did. They put the robot through a series of tests on those challenging terrains.
Yeah.
The stepping stones, the balance beams, even those gaps. And it navigated them all with a very high success rate, maintaining its balance and adjusting its steps as needed.
Okay, so we're not just talking about a robot wobbling across a beam. This is like controlled, confident movement.
Exactly. Much more controlled.
Wow, impressive.
Yeah, and then they took it a step further. They introduced these agility tests where the robot had to navigate the terrain at different speeds.
Okay.
So this really demonstrated its ability to not only balance, but to do so dynamically while controlling its momentum.
So it's more than just slow and steady wins the race. This robot has some pep in its step.
It does.
That's awesome.
Yeah.
But of course, the real world, it isn't always kind.
No, it's not.
It's full of bumps and nudges and all sorts of things.
Right.
So did they test for that? Did they do any, like, robustness tests?
They did. They really put this robot through boot camp.
Yeah. Oh, so?
Well, they added weight to the robot carrying a payload,
Mm-hmm.
and they even applied external pushes to see how well it could recover from those unexpected disturbances.
So they were, like, literally shoving this robot
Pretty much.
to see if it would stay on its feet.
Yeah, and it did. It passed with flying colors. It maintained its balance even with that extra weight, and even when it was pushed, it was able to quickly regain its footing.
Wow, that's really impressive.
And what's even more fascinating is what happened when they introduced the gaps.
Okay.
So remember, the robot was specifically trained on stepping stones and balance beams?
Right. Those were its specialties.
Right. Well, despite never encountering gaps before,
Yeah.
the robot was able to successfully navigate them.
No way.
It's true. It basically took what it had learned about balanced foot placement and adapting to those unexpected challenges and applied it to this totally new situation.
Now, that's what I call thinking on its feet.
I like that.
It took those skills and transferred them to, like, a totally different context.
Exactly. So it wasn't just rote memorization of specific obstacles.
Right.
The robot was actually learning and adapting.
That's huge.
It is. It's something called zero-shot transfer.
Zero-shot transfer.
Yeah. The robot was able to generalize its knowledge and apply it to a novel situation, which is a really big step forward in robotics.
Yeah, for sure. It's like a glimpse into a future where robots aren't limited to these pre-programmed tasks.
Right.
But they can actually learn and adapt on the fly.
Exactly. It's really exciting.
This is seriously impressive.
Yeah.
We're talking about robots that can not only walk like us, but learn and problem solve in real time.
It's pretty amazing.
So where do you see this kind of technology heading in the future?
Mm-hmm.
What's next for robots like this?
Well, as remarkable as these results are, it's important to remember that we're still kind of in the early stages of this type of research.
Go ahead.
There's so much more to explore.
Like what?
Well, for example, the environments they tested in this research were still relatively controlled. They involved, specific types of obstacles with clear boundaries.
Right.
But the real world, it's a lot messier.
Yeah, for sure.
Think about a search and rescue robot navigating a collapsed building or an exploration robot going through like a dense forest.
Yeah, the terrain is unpredictable. There are obstacles of all shapes and sizes.
Exactly. It's a whole other level of complexity.
For sure.
Yeah.
So one of the big challenges moving forward is how to enable robots to handle those, like, truly unstructured environments.
It is. And it's not just about improving their physical capabilities. It's about enhancing their perception and decision-making abilities.
Okay.
They need to be able to analyze these complex environments, identify safe footholds on the fly, and make these split-second decisions about how to move.
So it's like combining the physical prowess of a parkour athlete with the strategic thinking of a chess grandmaster.
That's a great way to put it.
Yeah. And we can't forget about the hardware.
Of course not.
The robots used in this research were still pretty sophisticated and expensive.
Yeah, they were.
So to make this technology truly viable for, like, real-world applications,
Yeah.
we need to make it more accessible and affordable. We need robots that are more robust, require less maintenance, and can operate for longer periods without needing a recharge.
Exactly.
So we've got the brains, we've got the brawn, and now we need the budget-friendly version.
Exactly. We got to make it practical.
It's fascinating to think about all the engineering that goes into building a robot that can even just walk,
Oh, yeah.
let alone one that can, like, navigate all this complex terrain that we've been talking about.
It's really amazing.
It is. But as these robots become more advanced, and potentially even more autonomous,
Yeah.
it makes you wonder about the bigger picture.
Yeah, definitely.
Like, what are the implications of having robots that can move and adapt so well in the real world?
That's a really important question. And, as we make these leaps in technology, we can't lose sight of the impact, both the good and the bad.
For sure.
We need to think about the ethical and societal implications alongside all the amazing technical stuff.
So what kind of ethical considerations are we talking about here when you've got these, like, agile, adaptable robots potentially out there operating in the world?
Well, one of the biggest ones is safety.
Right.
These robots, especially as they become more autonomous, are going to be interacting with humans more and more.
They're in, like, all sorts of environments.
Exactly. So we have to make sure they can operate safely.
Makes sense.
We need really strong safety protocols and fail-safes built in so that we can prevent accidents or any unintended harm.
It's like those Asimov laws of robotics, but, like, in real life.
Yeah, exactly.
Yeah.
We need to make sure these robots are programmed to avoid causing harm.
Absolutely.
Hmm.
And it's not just about preventing, like, physical harm, right?
Oh, you're right.
We also have to think about the data that these robots are collecting.
That's a good point.
With all these sensors like LiDAR, they're gathering so much information about their surroundings.
Yeah, they are.
So we need, like, clear guidelines around data privacy
Oh, I do.
to make sure that all that information is handled responsibly and ethically.
Absolutely. We need transparency and safeguards to prevent misuse.
Right. It's not just about the robot's actions, but also the information it's gathering
Right.
and how that data is used.
For sure.
Okay, so then there's also the societal implications to consider.
Yeah.
As these robots become more capable of doing things that humans currently do, like how will this impact the workforce? Will it displace jobs or create new ones?
It's a valid concern, and it's something that comes up a lot with automation.
Yeah, like the fear that robots are going to take over our jobs.
Right. But, I think it's not necessarily about robots replacing humans,
Okay,
but more about how we adapt and work alongside them.
right. Find that balance.
Exactly. Maybe robots can take on those more dangerous or repetitive or physically demanding tasks,
Yeah, that makes sense.
which would free up humans to focus on roles that require more creativity or critical thinking or, social intelligence.
So it's not man versus machine.
Right.
It's more about collaboration.
It is. It's about finding that balance where technology helps us and makes us better.
Well said. This has been such an incredible deep dive.
It has been fun.
We've covered so much from, the nitty-gritty details of foot placement and pressure maps
Yeah, all the technical
to
stuff.
the broader implications of robotics on society.
It's a big topic.
It is. And it's clear that we're on the cusp of some really transformative advancement.
Oh, absolutely.
We've talked about the challenges, the ethical considerations.
You're right.
But let's not forget the sheer ingenuity and brilliance that's driving all of this.
Yeah, it's really inspiring to see what people can do.
It is.
Yeah.
So what's the one thing you really want our listeners to take away from this deep dive into BeamDojo and the future of robotics?
I think the biggest takeaway is that this technology has the potential to change our world in big ways.
Yeah, for sure.
And it's up to all of us to be part of the conversation, to consider the ethical side of things, and to work together to make sure these advancements lead to a better future.
Well said. It's about shaping the future we want, not just letting it happen to us.
Exactly. We have a responsibility to guide these advancements in a way that benefits everyone.
Couldn't agree more. So
Good.
to all our listeners out there, keep exploring, keep learning, and keep asking those big questions.
The future is waiting.
It is.
Yeah.
It really is.